everybody, welcome back. Today we're looking at some other different patterns in math. A lot of times, I teach 6th grade, for example. A lot of students are dealing with unit rates, different inputs and outputs that are later used in algebraic equations, 7th and 8th grade. Let's take a look at some of those examples you may see now that you can play with to start getting an idea of how to look at patterns and identify them in a simplified setting. So we notice we have some numbers here, 5, 10, 20, 35, 55, 80. Not a very obvious pattern, but let's see what we can find. Let's see, from 5 to become 10, I could multiply by 2. That checks out. 5 times 2 is 10. 10 to become 20, hey, that checks out again. Times 2, 20 by 2, we have a problem, don't we? 20 by 2 is not 35. So let's go back to the drawing board. What else can we find? Well, 5 to become a 10, can't multiply anymore, simply not going to divide. What about adding? Okay, 5 plus 5 gives me 10. 10 plus 5, well, it's not 20. So what else can we do? This added 5. Well, to make 10 become a 20, that would have to add 10. Okay, 5, 10. I notice a pattern here. 5, 10. What about 15, counting by 5s? 20 plus 15 does make 35. I continue my patterns of 5, 5, 10, 15, 20 now. Okay, 35 plus 20 does make 55. Continue our patterns of 5, 5, 10, 15, 20, 25, very nice. There we go, add 25, 55 and 25 does give us 80. So what's our pattern here? These are all different numbers. Mickey, this isn't a pattern, but it is. We're noticing we're increasing by values of 5 as we continue to go up. We first added 5, then 10, 15, 20, 25. Not the most common. Students will say it's always adding by 5, always adding by 10, or by 7, or by 6, or whatever number it might be. Sometimes as you get into the older grades, 7th and 8th grade, it's an exponential growth that's controlled. So that's one example. Let's look at another example here. We have 3, 6, 12. All right. We pause here, take a look at this one. We have 3, 6, 12, 21, 33. They look like they have nothing in common other than the fact that they're multiples of 3. So it might have something to do with 3. So let's take a crack at that first. 3 to become 6, hey, that's times 2. 6 to become 12, hey, that's times 2 also. Wait a minute, we had that first up here. So there might be some other pattern here that maybe you're picking up on at home. See if you can pick it up as well as we continue on. But 12 times 2 is not 21. Just like the 5s, multiplied by 2 for the first two, but after that it didn't work. So let's try our example from before. We added 5, 5 make 10. How do I make 3 become a 6? Let's add a 3. Okay, well 5 went to 10, it was the next multiple. Let's go to the next multiple of 3. 3, also add 6. 6 plus 6 is 12. Next multiple, 5, 10, 15, do the same thing. 3, 6, 9 now. I add 9, 12 and 9 is 21. 3, 6, 9. What's our next one? 12, very good. Add 12. 21 and 12 does give me 33. So we notice again another pattern, even though it's not the same counting by 5s, just like before. It didn't end up being counting by 5s, it was counting by exponential increases or multiples of 5. Down here we see the same concept, but now with multiples of 3 increasing in value. Again, we see an exponential growth. Those of you students going from 6th to 7th to 8th or even 9th grade, you'll begin to see algebraic expressions not just using the same pattern over and over, but we see there's a relationship between the pattern that's a little more advanced, requires you to think a little deeper into the box, but it's always possible. Just be comfortable with patterns and see what you find, see if it works.